Welcome. In this activity, you're going to learn how to create your own solar system. You've got three choices. You can design a hypothetical system of your own design, or you can recreate a system from your favorite sci-fi movie like Star Wars or Star Trek, or you can recreate an actual exosolar system. That's a solar system in orbit around a star other than the Sun. On your assignment page, right underneath the link for this YouTube, you'll see the program that allows you to generate your own solar system. Let's click it. Okay, we have a solar system right now that consists only of the Sun. Let's change this. I'm going to give you an example. We're going to recreate an exosolar system. Wikipedia has a nice list of them. List of multiplanetary systems. If we scroll down, we can see this list. It's a very, very long list. There's lots of exosolar systems known. Let's choose the very first one right after the Sun. A star called YZ Ceti. And let's click this link. And as we come down, we'll notice there's a lot of information here about the star, the mass, the radius, the temperature. The only one of these pieces of information we're going to need is the star's mass. And then down here we've got the planets of the system. We have planets B, C, D, and unconfirmed is planet E. Well, the first thing I'm going to want to do is I'm going to want to change the word Sun. I'm going to want it to be YZ Ceti. So I'm going to go to this menu called Autopilot. I'm going to type now, and I'm going to type this in exactly as is. Capitalization is important. OBJ, that's lowercase, capital N for name, AME, those are lowercase, bracket 1, close bracket. That means the name of the first object of the system equals quotes YZ space CETI semicolon, and I'm going to press update, and our star has a new name. And we can press the red X to get rid of that box. We can also see that this star has a mass of 0.13, and look at this symbol here. It's a capital M with a circle as a subscript, and it stands for solar mass. If I hover the mouse over that, you can see that. So 0.13 solar masses. In order to change that, I'm going to go to the Objects menu, and I'm going to say Edit Object. And I'm going to change camera B to the Sun. And what was our new mass? We needed 0.13. So right here, it says mass. It has units of EM. Those are Earth masses. I'm going to want to click this. It changes it to JM, which is Jovian masses or Jupiter masses. And I'm going to click it one more time, and that's solar masses. So right now it's set for one solar mass, and we want 0.13. 0.13, and I'm going to hit apply. Notice up here it said Sun. Don't worry, that will change later when we start adding planets. It will become YZ Ceti. Let's start adding planets. The first planet we're going to want to add is planet B. It has a mass of 0.75, and the symbol right here is not the mass of the Sun. These are actually Earth masses. So 0.75 Earth masses. So I'd like to go to Objects, Create Objects, and the name of this object is going to be B, and the mass is going to be, right here it says kilograms. If we click kilograms, it turns into EM for Earth masses, and 0.75. Let's take a look at some of the other data in the table. Semi-major axis is the next piece of information we're going to need. You can think of the semi-major axis as the radius of the orbit. And this has a semi-major axis of 0.01557, give or take 0.00052 AUs. We're going to ignore the plus minus value. So I'm going to take this value here, 0.01557. I'm going to copy it and I'm going to paste it into the other page. You don't have to paste it, you can type it in by hand. And here it is, semi-major axis in AU, 0.01557, and the next two numbers, eccentricity and inclination, I'm not going to change those. I'll show you why. First, planet B has an eccentricity of 0.00. Eccentricity tells you how round the orbit is. An orbit with an eccentricity of 0 is perfectly circular, and an orbit with an eccentricity, that number can go as high as 1, would be an object in a very, very elliptical orbit about to escape the planet. So we're going to leave eccentricity alone, and inclination is not known for these objects, so we're just going to leave those alone too. So the mass is set, the semi-major axis is set, and we've given it a name. Let's hit create. And I'm going to close this box, and we're going to zoom in, and there's our new object. Very, very close to the star. Now I'd like to plot its orbit around the star. I'm going to go to the Objects menu, and I'm going to choose the last option, Orbits, and I'm going to choose B, Planet B, and I'm going to say Generate, and there's its orbit. Okay, let's add Planet C. Planet C has nearly the same masses here at the 0.98 Earth masses. Let's enter that first. Object, create objects. I'm going to change B to C. Earth masses 0.98. And back over here, let's see what the semi-major axis is for Planet C. I'm going to copy that, 0.02090. Semi-major axis. Paste. And I'd like to change the color. Here we have red, green, blue values. The color of object B's orbit is purple, which means it's most heavily in the blue, 255. These numbers can go from 0 to 255. Let's lower blue to 128, and let's increase green to 255. This should give us more of a greenish orbit. And let's hit create. We can close this box for the moment. And here we see we have object C. Again, I'd like to see its orbit, so I'm going to come out here, orbits, objects, orbits, and I'm going to choose C and generate. All right, our solar system is starting to come together. Now let's add planet D. Planet D has a mass of 1.14 Earth masses. Object, create objects. I'm going to call it object D. Let's give it a new color. Let's set this to 128, and we'll set the red to 255. These colors are totally your preference. Okay, D was 1.14 Earth masses. And D has a semi-major axis of 0.02764. I copied that number. I'm going to paste it. Now, while planets B and C had virtually no eccentricity, C had a very small amount, I forgot to give it that, but object D has a very large eccentricity. 0.129 is a pretty big eccentricity, and you're going to notice that its orbit is noticeably out of round. 0.129. Let's go back in here, and let's change eccentricity to 0.129. Okay, we have our name, we have our new color, we have our mass, our semi-major axis, our eccentricity, and let's hit create. And there we have object D. Now let's plot its orbit. Object, orbits, we're going to select D, we're going to hit generate, and as expected, the orbit of object D is not nearly as circular as the orbits of B and C. Now let's add object E. Object E says unconfirmed. We're going to include it anyway. Object E has a mass of 0.472 Earth masses. .472 Earth masses. Its name is object E. Let's make object E perfectly red. We're going to leave red at 255. We're going to take green and set it to 0. Blue, set it to 0. There's no blue or green in this color, and red is maxed out. And we've got the mass set. Now let's take a look at the semi-major axis. E has a semi-major axis of 0.01018. So it's actually closer than the other three planets. I'm going to copy and paste this so I don't make a typo. Semi-major axis, 0.01018. And the mass, I think, was a little bit less than that. E has a mass of 0.472 Earth masses. A little less than half of Earth's mass. Any other information in here we need? Eccentricity is 0. Inclination, not known. So we're set. I'm going to press create. And here's our new object E inside the other objects. Let's plot its orbit. E, generate, and here's our solar system. If we want, we can pan around and take a look at our solar system. We can press the play button and watch the planets move. Remember what we learned earlier. The planets that are closest to the star are going to move the quickest. They're going to take the least amount of time to go around because they have the shortest path and they're moving faster. I'm going to slow down the time step here, make it a little more watchable. I'm going to turn off and then turn on the trails, and that will fill in the extra little gaps. I can even turn off the orbits if I want, and I can watch them draw the orbits as they move. Well, now that I've built my solar system, I'm probably going to want to get some credit for it. So I'm going to show you how to save this solar system. It will also generate a link for you that you can share with your parents and your friends. I'm going to say File, Save As. I'm going to give this simulation a name, and I want you to name it exactly in this method so that I can find it. You're going to put down your last name. In my case, that's done. My underscore, first name, and underscore, I'd like you to put your block. So block 1B, I don't care if that's uppercase or lowercase. You don't have to fill in anything else. If you'd like to give a description, that's wonderful. If you've made your own hypothetical solar system, a description sure would be nice to let us know what you were thinking. You can put your name in here too if you like. Don't click either of these buttons. The top one should be clicked, the bottom one should not be clicked, and you're going to hit the save button. And it takes a few seconds, but a few seconds later, right here you get a big link. And if we want, we can copy this link. We can say save link as, no, not save link as. We could say open this link in a new tab. And here's our solar system. Press play. And there it is. Okay, I hope you enjoyed this. Have fun making solar systems.